On February 20th, 1943, north of Kasserine Pass in Tunisia, German tank commanders witnessed something that would never be fully explained in their battle reports. American Sherman tanks were performing coordinated maneuvers that seemed to defy the fundamental principles of Wehrmacht doctrine, all without any visible means of communication. Through the swirling dust and thick smoke of the North African battlefield, 5 Sherman tanks moved with remarkable precision. These vehicles were separated by broken, uneven terrain with no direct line of sight between them, yet they converged on German defensive positions with timing that appeared almost supernatural to the observers. There were no signal flags waving, no colored flares arcing through the sky, no motorcycle dispatch riders racing frantically between the vehicles to relay orders. Despite these limitations, the American tanks operated as though they shared a single mind. Each Sherman covered the vulnerable blind spots of its companions. Each crew member somehow knew exactly where their fellow tanks were positioned across the battlefield. This level of coordination seemed impossible without some form of direct visual contact. Meanwhile, the German Panzer IV tanks, equipped with what were considered modern Fugue 5 radios, struggled with a different reality. Their tank commanders found it difficult to hear transmissions from their own company leaders through the overwhelming static that plagued their amplitude modulation communication systems. The 10-watt German transmitters, which had been state-of-the-art technology by 1930s standards, could barely penetrate beyond a few hundred meters when the tanks were in motion across rough terrain. The situation was even worse for most German tank crews. The majority of their tanks carried only radio receivers, which meant they could listen to orders, but had no ability to report what they were seeing or call for assistance when they encountered trouble. What the Germans didn't realize was that they were facing an opponent equipped with technology they didn't even know existed. The American forces were operating with frequency modulation radios installed in every single tank. These radios featured crystal-controlled precision tuning, 25 watts of transmission power, and signal clarity that could cut through engine noise and battlefield chaos with remarkable effectiveness. From assembly lines located 8,000 miles away in Detroit, the most decisive technological advantage of World War II was revealing itself on the battlefields of North Africa. This advantage wasn't measured in armor thickness or gun caliber, but rather in the invisible electromagnetic waves that connected every American tank crew in ways the Wehrmacht had never imagined possible. The birth of a revolution, July 22, 1941. The transformation of American armored communications began on July 22, 1941, when the United States Army made a critical decision. They standardized 3 Signal Corps radio sets, the SCR-508, SCR-528, and SCR-538, for installation in all medium tanks. At this same time, German forces were advancing deep into the Soviet Union, employing tactics that heavily depended on radio communication between command vehicles. Meanwhile, in America, engineers at the Galvin Manufacturing Company, which would later become known as Motorola, were perfecting frequency modulation technology that would eventually make German radio systems obsolete. The engineering team working on this project included several brilliant minds. Daniel E. Noble conceived the innovative application of FM technology specifically for military vehicles. Henryk Magninski, serving as the principal RF engineer, successfully solved the considerable technical challenges involved in installing sophisticated electronic equipment inside the harsh environment of a combat tank. Their creation was substantial, weighing 181 pounds, but it effectively transformed every Sherman tank into a node in what would become the world's first true battlefield network. The BC-604 transmitter at the heart of this system generated 25 watts of power, which was 2.5 times the output of the German WWII system. Operating in the frequency range of 20.0 to 27.9 MHz, it provided 10 preset channels with crystal-controlled stability that ensured reliable communication. The dual BC-603 receivers included in the SCR-508 system allowed tank commanders to monitor multiple frequencies simultaneously, a capability that would prove absolutely decisive in combat situations. However, the real revolution lay in the nature of frequency modulation itself. Edwin Armstrong's FM technology, which had been licensed to the military, eliminated much of the static and interference that plagued amplitude modulation systems. While German tank radios picked up every electrical discharge from the engine and tracks as disruptive noise, American FM radios delivered remarkably clear voice communication even during intense artillery barrages. On November 8, 1942, Operation Torch brought American armored forces to the shores of North Africa. The 2nd Armored Division's tanks landed near the coastal towns of Safi and Fadala, equipped with their SCR-508 radios that would soon demonstrate clear superiority over German communications equipment. The Afrika Korps, despite being recognized as the Wehrmacht's most experienced and capable armored force, operated under severe communication limitations that would prove increasingly problematic. In a standard German tank platoon consisting of 5 vehicles, typically only 1 or 2 tanks would be equipped with full WWII transceivers, capable of both transmitting and receiving messages. The remaining tanks in the platoon carried only WWII receivers, which meant they could hear orders from their commanders, but couldn't respond verbally or report enemy positions they observed. German tank platoons therefore functioned through a rigid hierarchical system. The platoon leader would transmit orders that subordinate tanks were expected to acknowledge through their actions rather than through words. When command tanks were destroyed in combat, and they were easily identified by their distinctive multiple antenna configurations, entire platoons would lose their coordination and become significantly less effective. This vulnerability would prove catastrophic when facing American forces, where literally every single tank could assume command functions if necessary. The Battle of Kasserine Pass, February 14th to 24th, 1943. The Battle of Kasserine Pass, which took place from February 14th to February 24th, 1943, provided the first major demonstration of American radio superiority in action. Although it is often remembered as a tactical German victory, it revealed American capabilities that genuinely stunned Wehrmacht observers. During the confused and chaotic fighting, scattered elements of the U.S. 1st Armored Division maintained effective coordination across approximately 50 miles of battlefield. Tank crews who had never met each other before were able to coordinate their attacks, warn one another about emerging threats, and call for artillery support through crystal-clear FM communications. German signals intelligence units intercepted these American transmissions and noted with concern the exceptional clarity and level of coordination they observed. The 10th Panzer Division's intelligence section reported that American units were maintaining effective communication at ranges where German radios produced nothing but useless static.
Even more disturbing to German commanders was the realization that every single American tank appeared capable of full two-way transmission, not just specially designated command vehicles. The German WWII radios operating on amplitude modulation in the 27.0 to 33.3 MHz frequency range suffered from fundamental technological limitations. The 10-watt transmitter struggled to reach 2 to 3 kilometers even in ideal conditions, and its effective range dropped to mere hundreds of meters when the vehicles were moving. Every spark plug firing in the engine, every electrical motor running, every movement of the tank tracks generated electromagnetic interference that AM systems simply couldn't filter out effectively. The Italian Campaign, September 1943. September 1943 brought American armored forces to Italy, where the mountainous terrain should theoretically have negated many of the advantages provided by radio communication. Instead, FM technology proved even more valuable in these challenging conditions that rendered German AM radios almost completely useless. The SCR 508's frequency modulation system handled the complex multipath interference created by mountain valleys far better than amplitude modulation could manage. American tanks successfully coordinated their movements through terrain where visual signals were completely impossible, and German radios failed entirely. During the difficult advance toward Cassino, American armored units demonstrated capabilities that fundamentally contradicted what German doctrine said was possible. Tank platoons, separated by intervening ridgelines, were able to coordinate precision attacks that German military theory insisted required direct visual contact between units. The 1st Armored Division's after-action reports routinely described successful coordination at distances where German radios produced only static and garbled noise. D-Day and beyond, June 6, 1944. On June 6, 1944, as Sherman tanks rolled off landing craft onto the beaches of Normandy, their SCR 508 radios maintained reliable contact with naval fire support vessels offshore, a type of coordination that would have been completely impossible with German technology. However, the subsequent hedgerow fighting in Normandy revealed a critical gap in American communications. Tank radios couldn't communicate directly with infantry radios because they operated on different, incompatible frequencies. The infantry's SCR 300 radios operated in the 40.0 to 48.0 MHz range, while tank radios used the 20.0 to 27.9 MHz range. This communication gap proved deadly in the dense bocage countryside, where German infantry armed with Panzerfaust anti-tank weapons could approach American tanks while nearby American infantry had no way to warn the tank crews of the approaching danger. American forces characteristically solved this problem within weeks through innovation. Tank crews began mounting EE-8 field telephones in ammunition boxes that were welded to the tank exteriors, with the phones wired directly to the internal communication systems. By the time Operation Cobra began in late July, this simple but effective modification had revolutionized tank infantry cooperation on the battlefield. Operation Cobra, July 25th to 30th. Operation Cobra, which took place from July 25th to 30th, 1944, demonstrated the full potential of American radio superiority. The 2nd Armored Division, commanded by Major General Edward H. Brooks, successfully coordinated over 200 Sherman tanks through radio networks that enabled unprecedented levels of battlefield control. German defenders from the Panzer Lehr Division faced an enemy that seemed to possess an almost supernatural level of battlefield awareness. American tanks responded instantly to threats that had been reported by other units located miles away. Artillery strikes, coordinated through the tank radio networks, arrived within minutes of initial target identification. The contrast with German capabilities during this period was stark and tragic. Panzer Lehr, which had once been Germany's premier armored division, had been reduced to what can only be described as communication poverty. Most of their tanks operated without any radios at all, depending entirely on visual signals in terrain where visibility rarely exceeded 100 meters. The few functioning radios they possessed suffered from severe interference and such limited range that effective coordination was nearly impossible. The irony of this situation was profound and bitter. Germany had actually pioneered the use of radios in armored warfare in the 1920s and 1930s. Heinz Guderian, the architect of Blitzkrieg doctrine, had insisted on radio equipment in tanks since the 1920s. His influential book, Achtung Panzer, published in 1937, had emphasized communication as absolutely essential to effective armored operations. Guderian had personally developed radio communication systems that enabled tank officers to coordinate complex attacks. He understood deeply that rapid armored advances required reliable communication infrastructure. Yet by 1943, German tank production couldn't provide the radios that Guderian's own doctrine demanded as essential. German production statistics from this period revealed the extent of the crisis they faced. In 1943, Germany manufactured about 5,700 medium tanks, but produced fewer than 2,000 FUG transceivers. Many of these radios were allocated to command vehicles and assault guns, leaving regular tank units desperately short of communication equipment.
Soviet tank forces suffered from even worse communication poverty during much of the war. The T-34, despite being the most produced Allied tank design, typically entered combat without any radio equipment whatsoever. Soviet doctrine relied heavily on flag signals and pre-battle planning, with catastrophic results against German forces in 1941. By 1943, the Lend-Lease program provided some relief to Soviet forces. American radios, including SCR-508 sets, began to equip Soviet command tanks, but even by the war's end, only approximately 25% of Soviet tanks carried any form of radio equipment. This comparison highlights the magnitude of American achievement. While the Soviet Union struggled to equip just 1/4 of their tanks with any radios at all, America had achieved 100% deployment of sophisticated FM systems across their entire armored force. American industrial achievement. Motorola's factory in Chicago represented American industrial mobilization at its absolute peak. Before the war, the company had manufactured car radios for civilian vehicles. Converting to full military production required complete retooling of their facilities and solving numerous unprecedented technical challenges. Each SCR-508 radio set required 2,748 individual components, all manufactured to exacting military standards. The BC-604 transmitter alone contained 474 capacitors and 385 resistors. The crystal oscillators had to maintain precise frequency stability despite extreme temperature variations and the constant vibration of combat operations. The production statistics tell a remarkable story of American industrial might. 1942, 3,800 SCR-508 family radios produced. 1943, 11,400 units produced. 1944, 24,000 units produced. Total wartime production, over 50,000 tank radio sets. This production miracle ensured that all 49,234 Sherman tanks manufactured during the war received sophisticated radio equipment, an achievement that no other nation even approached during the conflict. Technical advantages beyond FM.
The SCR-508's advantages extended well beyond simple frequency modulation technology. The crystal-controlled frequency stability meant that tank crews could preset their channels before battle and maintain perfect alignment despite harsh combat conditions. German FUG-5 radios, using variable capacitor tuning mechanisms, constantly drifted off their assigned frequencies during operations. The dual receiver configuration allowed commanders to monitor their platoon net and the company command net simultaneously. Orders flowed down the chain of command instantly, while commanders maintained continuous awareness of their subordinates' situations on the ground. The BC-606 intercom system integrated seamlessly with the radio equipment, allowing all crew members to alert the commander immediately to any threats they observed. Throat microphones and noise-canceling headphones enabled clear communication even during the chaos of combat. Many German tanks lacked intercom systems entirely, forcing crews to communicate through touch or by shouting over the engine noise. Power management provided another significant American advantage. The SCR-508 operated on either 12 or 24 volts, automatically adjusting to whatever power was available. The motor noter power supply provided stable, filtered electrical power that eliminated interference. German radios, which were powered directly from vehicle electrical systems, picked up every spark and electrical discharge as disruptive static. Tactical transformation. The tactical advantages of universal radio deployment fundamentally transformed American armored doctrine. The combat command structure, flexible task forces organized for specific missions, depended entirely on reliable communications infrastructure. American commanders could create ad hoc battle groups from different units on short notice, confident that they could coordinate effectively through their compatible radio systems. This flexibility genuinely baffled German commanders who were accustomed to rigid organizational structures that were necessitated by their limited communications capabilities. During the Battle of Aracourt in September 1944, the 4th Armored Division faced multiple German Panzer brigades equipped with superior Panther tanks. The Germans held every apparent advantage in armor protection and firepower, but American radio coordination proved to be the decisive factor. Every Sherman could report enemy positions instantly to the entire force. Tank destroyers received precise targeting information from tanks they couldn't even see. Artillery observers riding in Sherman command tanks could call in devastating barrages within minutes of identifying targets. Over the course of 3 weeks of intense fighting, the 4th Armored Division destroyed 281 German armored vehicles while losing only 41 Shermans, a remarkable 7-to-1 kill ratio that completely defied what the technical specifications of the vehicles would have predicted. Throughout the entire war, German intelligence services failed to fully grasp the significance of American communication superiority. Combat reports mentioned American coordination abilities, but consistently attributed them to superior training rather than technological advantages. A captured intelligence assessment from September 1944 stated, "American tank units demonstrate good radio discipline and coordination. This appears to result from extensive training and rigid communication procedures." The report completely missed the fundamental technological advantage that made this coordination possible. German tactical doctrine never adapted to account for American capabilities. They continued targeting supposed command tanks based on antenna configurations, not realizing that every single Sherman could coordinate battlefield responses. They planned ambushes assuming American tanks would lose coordination when separated by terrain, not understanding that radio contact maintained unit cohesion regardless of visual contact between vehicles. The Rhine Crossing, March 1945. In March 1945, as American forces approached the Rhine River, their communication superiority reached its peak effectiveness. The unexpected capture of the Remagen Bridge demonstrated the incredible speed of American command and control systems. When the 9th Armored Division discovered the Ludendorff Bridge still intact and captured it, radio reports reached 1st Army headquarters within minutes. Within a single hour, divisions across the entire front were already shifting their movements to exploit this unexpected opportunity. German forces, dependent on telephone lines that American aircraft had systematically destroyed, simply couldn't respond with comparable speed to this changing situation. American radio coordination created an impenetrable defense of the bridgehead. Tank platoons from different battalions integrated seamlessly, coordinating their fires through the radio networks. German counterattacks, poorly coordinated due to their communication failures, arrived piecemeal and were systematically destroyed. The Ruhr Pocket, April 1945. In April 1945, the encirclement of the Ruhr Pocket demonstrated the culmination of American communication superiority. American armored columns from the 1st and 9th Armies coordinated a complex double envelopment maneuver entirely through radio communications. Inside the pocket, 325,000 German troops found themselves trapped, partly because their communication systems had essentially collapsed. American fighter bombers, guided by radio-equipped forward air controllers, systematically destroyed German communication nodes and headquarters. Wehrmacht units progressively lost contact with higher headquarters and with each other. Field Marshal Walter Model's final messages before complete communication failure revealed the desperate German situation. No contact with adjacent units, no communication with higher headquarters. Fighting continues, but coordination impossible. The psychological dimension. American radio superiority profoundly affected the psychological experience of tank warfare for both sides. American crews fought with the comforting knowledge that they were never truly alone. Even when physically isolated on the battlefield, they remained connected through radio waves to their comrades. German tank crews experienced the opposite reality, profound isolation. Unable to communicate effectively, they fought individual battles within larger engagements, never certain of what was happening beyond their immediate field of view. Otto Carius, one of Germany's most successful tank commanders, wrote in his memoir, Tigers in the Mud, about the considerable challenges created by limited communications, though he focused more on tactical aspects than on the communication gap itself. Strategic implications. The strategic implications extended far beyond individual battles. American advances during 1944 to 1945 maintained their rapid tempo, partly through radio coordination that German forces simply couldn't match. The Third Army's famous race across France depended on radio networks that maintained effective control across hundreds of miles of territory. German commanders consistently underestimated American capabilities because they genuinely couldn't conceive of the level of communication superiority Americans possessed. Heinz Guderian, in his role as Inspector General of Armored Troops, recognized the problem, but couldn't solve it given Germany's resource constraints. In a memorandum from December 1944, he acknowledged that American coordination capabilities were negating German advantages in tank quality. Post-war analysis. After Germany's surrender, American technical intelligence teams conducted thorough evaluations of German equipment. Their findings confirmed what combat experience had already suggested.
German tanks often possessed superior armor and armament, but they had catastrophically inferior communication systems. U.S. Army Technical Intelligence Report number 176 concluded, German tank communications equipment was approximately 5 years behind American systems. The absence of frequency modulation, limited radio distribution, and poor electrical suppression created critical vulnerabilities that significantly impacted combat effectiveness. Soviet evaluators reached similar conclusions after examining captured German equipment. The Red Army, given access to German technology, chose to copy American radio designs rather than German systems for their post-war development programs.